Function notation. We're going to also look at functions in graphs and tables. So to review function notation, f of x is just another way to write y equals. So again, f of x is the same as y equals. We've seen that in our calculators, f1 of x, and then we type in the equation. So let's say we have this function, f of x equals 10 minus x squared. So this is telling us this is a function. Evaluate the following. F of negative 2 means plug in a negative 2 for x. So let's do that. We have 10 minus, and instead of x, let's plug in what x equals. Substitute in the negative 2, and it's squared. All right, let's solve this. We have 10 minus negative 2 squared is negative 2 times negative 2, which is 4. And we have 10 minus 4, which is 6. So for our final answer, we're going to say f of negative 2 is 6. When we plug in a negative 2, we get 6 for an answer. Let's try the next one. F of 6 means plug in a 6 into x and solve. So we have 10 minus, and instead of x, we're going to plug in a 6 here, and we're going to square it. So here we have 10 minus 6 squared is 36. 10 minus 36 is negative 26. So for our final answer, we'll say f of 6 is negative 26. In other words, when I plug in a 6, I get negative 26 for an answer, the output. So 6 is the input, negative 26 is the output. 3 is slightly different. 3 is saying find the input x if the output f of x is negative 39. So this is giving us the output, the answer, negative 39. And they're saying find x. So we have 10 minus x squared. All right, first step, subtract 10 from each side. We get negative 49 equals negative x squared. Divide each side by negative 1. We get 49 equals x squared. And we're going to square root each side to get rid of the squared. The square root of 49 means what number times itself is 49. And there's two answers. X is 7. So when our calculator gives us. There's also another answer, x is negative 7, because negative 7 times negative 7 is also 49. But for this unit, if you can come up with x is 7, that will be good. Okay. So again, if I give you the input, you plug it in, give me the output. If I give you the output, you set it equal to the input, and you solve. All right, let's take a look at graphs that are functions. Again, this is a function. It would pass the vertical line test. For every input, there's only one output. And this says, what does g of 75 mean? So 75 is the x value, which is the independent variable, the thing on the bottom of the graph. So it's saying when the miles driven is 75, how many gallons are in the tank? So let's take a look at that. So here's 75. We're going to go up. We're going to go over. There's 12 gallons in the tank. So this means when 75 miles, when you drive 75 miles, what are driven, you have 12 gallons in your tank. All right, find g of 75. Okay, so we did that. G of 75 equals 12. This says, what does g of x equals 9 mean? It means when you have 9 gallons, so 9 gallons in your tank, how many miles have you driven? Okay, let's solve this. So this time they give us the output 9, so let's find the output at 9 and go over to our graph and go down. So when we have 9 gallons in the tank, we've driven 150 miles. Okay, so if I give you the output, go over and down to find the input. If I give you the input, go up and over to find your output. Okay, let's look at tables that are functions. Remember, for a function, every x has only one y value. Every x value every input only has one y value or output. So let's take a look at the first one. The first table, the input 4, we get a 1, 5, 1, 0, 3, negative 2, 5. This is a function because every input has one output. Even though 4 and 5 had the same output, if you were to graph that, it would pass the vertical line test. At 4, 1, 2, 3, 4, you'd have a dot, and at 5, you'd have a dot, and that would pass the vertical line test. Let's take a look at the next one. This one is not a function, and the reason is every time I put in the input 4, I should get the same output. And here when I put in a 4, I get a 1. But here when I put in a 4, I get a 5. So again, if I were to graph that, I would have two dots on the same vertical line, and that would not be a function. All right, it would be a function if this was a 1. Every time you see a 4, you should see a 1 for your output. All right, step 3, or question 3. Your science class is growing plants. You record the heights of your plants each day for 10 days. The plant's height in centimeters over time is listed in the table below. Use the table to evaluate the function at each value. Explain what each means in terms of the problem. So find h of 7. All right, so 7 is the input. Here's the input. Here's the output. And this means at day 7, the height is, and it's 14 centimeters. Let's check the next one. This means at day 3, the height is 7.2 centimeters. Okay, calculate the value of x that makes each equation true. Explain what it means in terms of the problem. All right, so now it's giving you the output. When the output's 10.5, what's the input? It's 5. So here, when the output, and I cut it off, when the output is 10.5, the input, so output 10.5, input 5, which means day 5, height 10.5. Let's take a look at the last one. And this is saying when the output's 17.3, how many days have gone by? So 17.3, 9 days. So again, if you write this up, at 9 days, the height's 17.3. So height is 17.3 after 9, or we can say at 9 days. So here x equals 9. So today you're going to take a look. We'll do function notation review, but we'll also look at functions and tables and graphs and be able to interpret them.